name is Megan Kelso, and these are my teammates, Kari, Ben, and Stephen, who is our team leader. We also have 4 mechanical engineering team members who have worked with us this year. Our corporate sponsor is Mentalix, which is a company that takes these paper fingerprint cards that you see here and scans them to make electronic copies, which are much more easily searchable. This could be used by the DMV or for criminal investigation or forensics or any number of companies where fingerprints are used. Mentalix has several scanning systems, which are all FBI approved, and they would like to update one of their scanners to a newer model, which unfortunately does not have an automatic document feeder, or ADF, that is compatible with it. They're looking for a robotic solution, which after the past year of hard work and research, we are able to provide them with, as well as improve their throughput by increasing the capacity of our input and output trays. As you see here, their old ADF can hold a maximum of 100 cards at a time, while our design can hold 500 cards at a time. The main parts of our design include the robotic arm, the Bernoulli cup, which you also see here, the input tray servos to adjust the height of the stack of cards in the input tray, 3 sensors, and this 3D printed cradle piece to hold each part of the system in place. We spent a lot of time over the course of the year trying to solve this picking up one card at a time issue, and we ended up with this Bernoulli cup in our final design. Using compressed air, it blows downward near the outer rim of the cup, which creates a lower pressure near the inside of the cup, and it's able to pick up a paper from even a small distance because of the pressure difference between the ambient air near the paper and the lower pressure air near the inside of the cup. It also prevents multiple paper grabs by using that blow from the air compressor near the outer rim of the cup to blow down on the stack of papers, while the inner area simultaneously grips. After we solved this one card at a time issue, we had some time to work on other parts of the project, such as this PCB, which we designed, as well as our input tray servos and our sensors. Our sensors include 2 photo cells, one near the Bernoulli cup to detect that a paper has been successfully picked up, and one on the bottom of the input tray to detect when it is empty. Our third sensor is a whisker switch, which works in tandem with the input tray servos to keep the height of the stack of cards near the top of the input tray. As far as individual efforts, Stephen and I worked on the programming various parts of the system. Ben and Kari worked on the PCB as well as other circuitry. And the mechanical side of our team worked on designing this 3D printed cradle system and ensuring that the white background would be behind the card for each scan to maintain high resolution. Thank you for your time, and I can now open up the floor for any questions you may have about our project.
I presume that the weight of the card is pretty much a constant, right?
Right, that's right.
What happens to your system when you deviate from that? I mean, you get cards in that are a little thinner and or a little thicker. So what happens to your system? You have how much tolerance you have in that mechanism?
The thickness of the card isn't really an issue. Since we spent so much time looking for this good suction gripper using compressed air, it works pretty well so that it can even pick up the card from a small distance. Like, it's contactless gripping, so the thickness of the card won't affect its ability to pick it up. And also, when we move to the scanner, we drop the card a little bit before we press the white background down, and we have bumpers in place to adjust the positioning of the card. So the thickness would be negligible, as well as the size of the cards, because they're all the same for this system.
Is it currently in use today?
Yes, we have it at our table at the end of tomorrow, because our mechanical team has to show it off. We'll be handing it over to our corporate sponsor, and they'll be handing it over to the FBI to get approved. Yes. So sorry.
What's the cost of building this?
The cost of our total project came out to about $1,800, but included in that cost is a lot of the 3D printed pieces that we didn't use. We used a 3D printer in the new UT Design building, and they gave us just one lump sum of how much we spent, but we had a lot of pieces during our research process that we're not actually using in our final
compressed air. Do you actually have a compressor, or do you just like a tank for compressed gas?
That's right, we have a compressor.
You have a compressor.
It's about, we found the quietest one we could find for a decent price, and it's about 60 decibels, which is approximately the loudness of a conversation.
What if there are two cars that are stuck together for whatever reason? Are you able to detect it?
Typically, that doesn't happen unless you pour water over the stack of cards. I'm not sure if Mentalix has
Actually,
some
yeah,
sort of humidity measurement.
in Mentalix's software, each of the cards has a barcode, so they can detect when a card is being used.
So if the barcode is missing, then they.
The barcode is missing when the FBI did not do their job.
Yeah, so, yeah, we make sure like every single scan ends up coming in. Then Mentalix actually has like programs to determine like whether or not it's, there was a card either missing or a card that ended up getting duplicated.
Right, so during the scanning process, we won't be able to detect if two cards have been picked up at the same time, although that hasn't happened after we purchased this Retrieval. But afterwards, you would be able to see it with the barcodes.
So compare human versus automatic document here and here input. How do you compare?
All right, throughput?
Yeah, how fast are you moving
Oh,
versus PDF over a person?
I'm not sure how long it takes a person to do it, but our system runs at about 1 minute per card. For the whole, moving from input tray to scan, including the time for scanning and moving to the output tray.
And then also the customer requested robotic solution, which was more of a preference than a